It's time to get started. Definitely a Friday attendance. We have our last set of chapters due Sunday. And if all goes well by the end of today, we'll be at the point where we can assign the paper. And I think we'll spend a little bit of time in class just working on that and balancing harmony, answering questions about cost curves as you get started on the process of working through this. But we have some examples to go through today so that you have some experience messing with cost curves and seeing how that works. Last time we talked about starting to create the math for cost curves. We talked about when the math wouldn't exactly work out, what additive and multiplicative benefits look like, situational benefits, what existing gray areas are there when using cost curves. But let's take a look at cost curves. So we talked about how when you're making a game, you can start to borrow a cost curve from a similar game if you can figure out the math behind that game, or if it's a game that you've designed something similar to, you can just start with an existing cost curve. But if you're designing a new game that doesn't have a baseline cost curve for it, then you may find yourself making one of these from scratch. So the more original and innovative your design is, the more challenging it's going to be to derive a cost curve. You won't be able to ground yourself in existing games. So you should start with a spreadsheet, documenting as much as you can about the game in that spreadsheet. And you will eventually find that you have formulas for just about everything. And those formulas will be your balance. They will tell you how over or underpowered a particular game object is depending on its power. So we want to make modifications to this as easy as possible. Make sure you're referring to other cells wherever you can, and you're not hard coding everything the same way that you do when you write programs. You don't want to, wherever you can make class constants, make things easy to pull out of. You don't have to go back in the code and make changes everywhere in order for things to work. The exact same thing works with a spreadsheet. Make sure that everything is out in a formula and not some formula for particular cells. So don't worry about perfecting on the first attempt. We just want formulas to be consistent and formulaic. Makes sense if a formula is formulaic. It kind of is by definition. But yeah, regardless of what you do, things will be off. You're never going to get this right on the first pass. And I don't like the saying practice makes perfect. I prefer practice makes better, because the end goal of this isn't to reach perfection. It's just to iterate and improve, iterate and improve. And the more experience you get with that, the better you will be at where things start. And the goal of all of this is just to get the game in a playable and testable state as fast as possible with balance that is relatively good so that you can determine what the issues are. You don't want to spend a lot of time thinking about the balance, and after weeks of thinking about the balance, you finally get to the playtest feeling like you've absolutely perfected the math, and there's still stuff off about the gameplay because the math can't be perfect. So get it in a testable state, a playable state, as quickly as possible so that you can iterate on that idea, figure out what feels wrong, go make those changes. Test again, just go through that iteration. And yeah, refine the balance as you play test. So we're going to go into a case study. We're going to actually spend some time balancing and working with an example. So imagine that we've designed a new trading card game. We like trading card games in here. Here are the rules of this trading card game. It's not hard. Characters battle one another. Cards have 3 numbers on them: their cost, strength, and damage. Here are the rules. We want to reduce an opponent's health to 0. Each player brings their own deck, only has 10 cards in it. After shuffling their deck, they draw an initial hand of 3 cards. Each player starts with 10 health. The game is played in a series of rounds. Each round has 5 phases: the select phase, the reveal phase, the battle phase, the damage phase, and the cleanup phase. Phases are repeated until one or both players are reduced to 0 health or below, at which point the game ends immediately. So there are not turns in this game. You're taking turns at the same time. In the select phase, you choose one card from your hand, place it face down in front of you. When both players have selected, you move on to the reveal phase, where both cards are turned face up. Each player loses an amount of health equal to the cost of the card that they played. So you lose health for the cost of the cards that you play. Remember that, yeah, losing happens immediately. So if you play a card that costs more than the remaining health that you have, nothing else happens. The game ends right then. So then we go to the battle phase. Compare the strength of two cards. So each cards have strength. If one card's strength is lower than the other, it's immediately discarded from play and has no further effect. If the strength is tied, both cards remain in play to the next phase. But the idea is only the highest cost card sticks around. For the damage phase, any card still in play does its listed damage to the opponent's health. Once that's done, we clean up. All cards in play are discarded. Players draw one card from their deck, and this process repeats. We go back to the select phase again. So, yeah, if a player's health is 0 or less, their opponent wins immediately. If both players' health is 0 or less, the game is a tie. If one or both players are completely out of cards at the start of the select phase, they have exhausted their deck, played on every card in their hand, then the player with the highest remaining health wins. So, rules make sense for this trading card game. Again, we've stripped as much complexity as we possibly can from this. It is a very straightforward, very simple game to play. You have 10 cards, hand size of 3 at the start of each turn. Select a card to play, reveal it. Whichever has higher costs sticks around. One of those cards is going to do damage to the opponent because it had higher cost than the other. And then we repeat that process. But you're taking health damage for the cost of your card, regardless of whether your card has further effect or whether it is immediately discarded. So that creates an interesting decision about which cards to play. Do you play the low-cost cards, taking very little damage to get rid of them? Do you play the high-cost cards, hoping that your opponent is playing a low-cost card so that they can get through and deal its damage? You don't want to play a high-cost card when your opponent plays a high-cost card. If their card costs more, that is a very bad outcome. So in this trading card game, we're going to start with as few cards as possible. We're going to make 4 cards. They are the Thief, the Cleric, the Fighter, and the Hero. Here is an initial balance of this. So we're initially designing these 4 cards. The Thief, the Cleric, and the Fighter all cost 1. The Hero costs 2. You can see their associated strength and their associated damage. So remember that cost is the health that you pay to play the card. Strength is the amount of that is compared to each other to determine which sticks around. And the damage is the amount of health that you deal if the card sticks around. So the first question I have for everyone, are these cards balanced?
Can you explain what strength and damage does again?
Yeah. So strength is when you have 2 cards that have just been revealed. We're going to discard the card that has less strength. The card that sticks around is going to deal its damage to the opponent's health.
Yeah, what happens in a tie?
Tie, both cards stick around for strength and both deal their damage.
Okay.
So just gut feeling. Gut feeling, are these cards balanced?
My first reaction would be for 1 cost. I don't know why you'd ever choose anything other than the Fighter, because you would just never lose if you have the highest strength.
That said, the 1 cost that it costs you in health to play the card is the amount of damage that you're dealing. So you're only whittling away the opponent's health at the rate that you are taking health. Of course, if they're paying anything that has cost, yeah, your fighter would beat that other card and stick around. So 1 and 2.
Obviously, in this case, we only have 4 cards, but since it's a deck of 10, are we assuming like you can't have duplicates?
Let's initially state that you can make a deck of any 10 subsets of, you can make 10 copies of any of these cards in any combination. How would you construct your deck in order to have a competitive advantage over someone else who is constructing their deck? Are there right decisions for constructing your deck?
I was
One,
gonna
two.
say, I'm gonna say something like the cleric seems like the worst card to go for because it deals good damage, but unless you're doubling up on playing it, it seems like it's the one character where
Yeah, it's always going to be eliminated unless your opponent also plays a cleric. In which case, there's no way to get a competitive advantage.
yeah. Oh,
Yeah.
I didn't even consider the idea of like I didn't understand like what the strength meant. I thought it was just like anything in your side you have to let me not if you're fighting both decks.
Yeah, that's if you're playing me, we're both going to reveal a card at the same time. The only way a cleric sticks around to deal damage is if we both reveal a cleric. If anyone else reveals anything else, they have higher strength than a cleric. My cleric is immediately discarded, and I paid 1 life.
Yeah.
That doesn't seem great. If it sticks around, it deals a lot of damage, but the only way it sticks around is if your opponent also has a cleric that's going to do a lot of damage. There's not a ton of upside to that play.
You keep the card equal.
It gets discarded.
It gets discarded.
Yeah, it does the damage, and then it goes into the discard pile.
Oh, sorry. I just want to. I don't know if there's another thing too, but like, I feel like that there's sort of a question regarding like hero. I don't know if I want to say on balance, but like, there's a problem with same thing with cleric. There's a problem with hero where it's like, I mean, if you're gonna have a hero, you probably don't want to have a fighter because obviously, like, well, I mean, I guess it's a kind. I didn't consider the cost. So I was just actually
Yeah, if you're constructing this deck from these 4 cards, what cards are you picking and in what quantity?
Would it depend on how big the deck is?
You get 10 cards in your deck.
You tie, your card still deals.
Correct.
So when you just want 10 heroes, so we could just do 5.
That is the equilibrium solution to this game. Yeah.
I was gonna say like, yeah, that was my idea of like, like you could just deploy heroes, but it's like, there's a second cost though. So it's like technically speaking, someone could like, I mean, I guess that's a question I should consider. Like at the pace that you would take for someone to deploy a hero, could you outpace them exactly?
Yes.
I guess it's like,
And the reason is, so if I choose 10 heroes in my deck and I play them, it's going to cost me 2 life to play a hero. I get 5 damage, and I know that 5 damage is going through because no other card has greater strength. So I'm guaranteeing a net of +3 damage to my opponent. If my opponent plays anything, thief, cleric, or fighter, the most they can do back to me is the fighter's 1 damage. They'll take an additional 1 damage to play the fighter and get through 1 damage to me, which is still a net of -3 for my opponent and +3 for me. So intuitively, it feels like the hero doesn't have a counterplay, except against other heroes. So the solution to this would be the only reason I would have 10 heroes in my deck. You would have 10 heroes in your deck. This game is now very boring. We're always going to tie. It's an even worse version of tic-tac-toe. So let's see if we can get the math to agree with our intuition. Because I think when we're designing a cost curve, it's one thing to just apply numbers to things, but it's also worth, in a simple example like this, tying the what would you do in this situation to try to see how the math might align to determine whether it's as imbalanced as we see in the directions that we see it. So let's start with, what's our anchor? Health. Yep, makes a ton of sense, right? If you have 10 health, your opponent has 10 health, pretty straightforward. So the cost, if we're trying to figure out how, remember that the value of a card is benefits minus costs. So we want to figure out what are the costs of playing a card. The cost is its cost in health to play. So now the next question to figure out is how much health is 1 point of strength worth? I'm going to leave this there for a while and see if you can get together in small groups and see if you can figure out how would you answer that question. If our anchor is health, we want to tie strength back to health in some capacity. So how should we value the benefit of points of strength compared to points of health? So have that discussion for a bit.
I didn't realize the strength mechanic is basically like Kingdom Hearts chain of memories, right? With like
Yeah. Yeah,
Oh, I didn't realize that.
yeah, because card with a higher value cancels a card of a lower value and the
Yeah.
damage goes through.
Yeah, it's like like basically like interrupt.
Yeah, it's a turn-based version of that, because Chain of Memories is action-based, so just because your attack cancels someone else's, their attack can cancel yours, but yeah, the turn-based version of that.
We're understanding.
Yeah, it is. Yeah. That's how you're going. Restricting.
So if you have the one when it's strength, that's worth how much damage you're gonna get up, because you can't win. Well, isn't given these were cards.
So we need to be, I think we do a lot of it. In your local. Lower than, yeah. I think image would be, because it's.
Remember that we're not trying to do a comparative analysis between the cards, we just want to be able to come up with a valid function that ties strength to health in some capacity. So what are there are two variables at play here. What are those two variables? So I think it's how likely your card sticks around and how much damage your card deals if it sticks around. So we should try to build some kind of function based off of that. Sorry. Yeah, the other part of that is if it removes your opponent's card, it prevents the damage that it would have dealt. So high strength means you're more likely to deal your damage and less likely your opponent is to deal their damage. So let's figure out how likely strength is to have an effect. Of course, that just depends on the card pool in the metagame, right? It makes sense that the relative value of strength will depend on the cards that are available, as well as if the meta is everyone has a hero, then it doesn't matter if the only cards that have value are cards with strength 5. We're going to make an assumption to make this process a little bit easier. So instead of having exactly the 4 cards that we have, let's assume that the design space for this is that we're going to have a large pool of cards, and it's going to be equally distributed in strength between 1 and 5, with each value appearing equally often. We're going to make an additional assumption that the opponent will play a card with strength 1 through 5 with equal probability. So what this means is if we play a strength 1 card, we're always taking damage from the opponent's card, and we have a 20% chance of dealing our damage to the opponent. If we play a strength 2 card, there's a 20% chance of eliminating the opponent's card and a 40% chance of staying in play to deal its damage to the opponent. So now let's see if we can come up with a formula. Given this is a bit more context, a bit more context here to be able to come up with a formula. So now, what does strength's formula look like? Now we should really be able to get an answer. Feel free to use a couple of variables in here. We need the card's strength cost. And we need the opponent's damage. This is just for damage prevention, not damage dealt.
So the chance they'll deal damage.
Yeah, the chance they'll deal damage and how much damage they're going to deal.
Wait a minute, how do we know how much damage they're gonna do?
That's just a variable we'll put in this formula.
Okay.
First of all, how do we get the probability that we cancel out their card? That's just a table. We're going based off of the first part of this. We play a strength 1 card. There's a 0 chance we play a strength 2 card. There's a 20% chance we play a strength 3 card. There's a 40% chance a strength 4 card. There's a 60% chance there's a strength 5 card. There's an 80% chance. So we need a part of a formula that converts left side to right side. Input, output. What is that? Card strength.
The 0.2 times n-1.
Yeah. We end up with strength minus 1 over 5, or exactly the same thing as multiplying it by 0.2. Then we just need to know how much damage we are preventing, and there's no way to know that based on the card. So we're just going to multiply this by the opponent's damage. Yeah, that'll do it. Questions on how or why? Makes sense. So we end up having to make some assumptions about the card pool as we do this, but it'll help us to be able to design cards later. So yeah, strength minus 1 over 5 times opponent's damage. What is the average opponent's damage? We will assume that the values of 1 through 5 are equally likely. So let's just say that the average damage is 3. So we can fully now say that we have strength minus 1 over 5 times 3. And now we actually have a numeric way to map a card's strength onto the amount of damage that it prevents. How much damage will our card do on average? What would that one look like? Going to be very similar, but slightly different. What is the difference?
3 times strength over 5.
Yeah. Yeah, instead of strength -1, it's strength. The chance that we eliminate the opponent's card is strength -1, but the chance that our card sticks around to deal damage, we have that as well if we tie. So that just becomes strength over 5 times the damage, and if our damage is an average of 3, then we can assume that that is an average of 3. So if we are going to have benefits minus costs, then we can start to plug some things in. We have our strength -1 over 5 times 3 plus strength over 5 times damage minus cost. That's basically, we've calculated the benefits. The benefits portion of this are the damage that our card will deal and the damage that our card will prevent by eliminating the opponent's card based on the chance that it will do that. And we had the cost as well, because that was just the cost of playing the card. So with some basic assumptions based on the distribution of all cards, we can now apply those back to the 4 designed cards that we had earlier on. So we see, if we do that, we can see the benefits minus the costs of each of the cards. What do we see? What do we notice?
Thief and fighter are
Thief and fighter are the same. Did we validate the choice of putting 10 heroes in our deck? We see that mathematically, even though this isn't absolutely perfect, we can see how the hero is imbalanced compared to the rest of the cards. So, one thing to note, all cards are above the curve. Remember that we wanted to say benefits minus costs is 0 whenever we could. Is this an issue? Turns out there's something we didn't take into account with our cost. What was it?
Max health.
Something to do with health.
Or start up, I should say.
What happens when our opponent's card gets through? Deals damage to us. So we didn't do that. We need to incorporate the average damage if our opponent's card gets through. If we do that, we end up with this. The cost is going to be an average of a cost plus 3. If they get through, then we're going to take an average of 3 damage. So we apply that formula, and we get this. So according to this mathematical estimate, playing a hero is going to, in an average world of costs and damages varying, strengths and damages varying between 1 and 5, a hero should get us a net of 2.4 health when we play it. If we play a thief, we should lose an average of 0.6 health. When we play a cleric, we should lose an average of 1 health. When we play a fighter, we should lose an average of 0.6 health. Will that actually be the case in practice? Probably not, because it will again depend on the exact cards that are available. The metagame, as decks aren't going to contain random assortments of these cards, players will strategize as to which cards are going to work well together or work well in their deck. But we can see that the first 3 cards are in general weak, below the curve, and the hero is drastically overpowered. What I want people to work on in groups. What changes can we make? Think about starting to modify costs, strength, and damage. And let's actually spend the rest of this class doing this. So in groups of between 2 and 4, try to modify the cost, strength, and damage such that we get these totals using the formula that we have, this new formula, to be as close to 0 as possible. What numerical changes would get us to that point? And then do a second pass. We can get the totals close to 0. Think about how the cards would play against each other. Is there still going to be a meta that evolves? Or have you created something like a thief beats a cleric, beats a fighter, beats a hero, beats a thief, etc.? How would this play out in practice, again, if you got the choice of which cards to put in your deck? So let's spend some time doing that.
What if you just increase the cost of the home?
I'll give you the hint now, that there are some good changes and some bad changes. You can make changes where it looks mathematically balanced, but in play, there's still going to be a meta that evolves that is the correct meta. And there are changes that you can make that make it look mathematically balanced, where you don't have an easy meta to figure out.
What is the, what is that? It's not what we did. It's not. We won't pay for it. When we move in, it's. G2. Is the home. So. The word we talking about. Equals. I was going to swear that we have to use that very.
Oh, man.
So it's 2.31. Stage. Or suitable.
How many changes would you make?
Well, I want to get these as close to 0 as possible. Since most of these aren't particularly extremely close to 0, I'd be thinking about making at least one change per card. But you don't want to make changes that make the cards identical. Like you wouldn't want to make a change to the cleric that turns it into the thief. We want there to be distinction between the cards, but we want if the card's value is negative, we want it to do more than it currently does. So we either want to decrease a cost, increase strength, or increase damage. If the value is positive, we want to increase cost, decrease strength, or decrease damage. And where the magnitude is larger, so for the hero, we're going to need more changes than we need to the other classes. So a small tweak might be necessary for the other 3, but something a little bit more drastic will be needed for the hero. And we don't want to change something in a way where the hero continues to dominate the way that it does. So what change would we make in order for the hero to have a weakness? The hero doesn't really have a weakness when it has high strength and high damage. Regardless of its cost, that's going to be something that is going to be optimal as long as it will dish out more damage than you receive.
This one. So, strength.
So to me, that says strength or damage absolutely need to change, if not both.
Oh,
But with a high cost, they should still be strong, but you want to create a weakness to the hero. What is that weakness? What can be exploited?
You're taking damage yourself, a lot of damage yourself.
Yeah, so that is a weakness. But if that is less damage than it deals, then you're always going to come out ahead as long as that strength is 5. So either you can make the hero have a high cost, lower strength, high damage, which makes it a risky play. It might be completely eliminated, and you take that cost for no benefit.
Well, then it shouldn't be called hero, because hero saves you.
Well, maybe you can do a little bit less damage then and be consistent.
Yeah, true.
where,
You can rename it if you'd like. You can make it weak hero or wannabe hero or.
Risky hero.
I found a way to balance them, but I'm not sure how to feel because it just basically amounted to narrowing down hero to just 4 strength, 4 damage. I'm not sure how to. It gives me a clean 0, but I'm not sure how to feel about that.
Yeah, that's a great place to be. It's mathematically balanced, great, but what is the play like? What is its strategy? Does it have a counterplay? It makes the fighter a much more interesting choice
Yeah.
because the fighter gets rid of the hero now.
Yeah.
But if you don't play a fighter, the hero sticks around and is still very powerful. So is now the right play just to pivot to fighter,
yeah.
a deck of 10 fighters.
Yeah, it's like it just changes the strategy to now you have like a pocket. You're just hoping for a pocket fighter. Basically.
Yeah.
Like denial.
Oh, because it's from the on all every time. Yeah, it's great. Okay, so what do you want to see? This. This. What about this? Wait, I want to see that. Safety can't be the right ones. We can just everyone down the house. Yeah.
So it's supposed to be.
So here, what did you change the costs?
Yes, but it also. This costs a lot.
You know, I will say that like the biggest problem I'm trying to figure out is like how do you balance around the objective like
remember still.
the worst case of that.
What is the station?
Oh,
Yeah.
You know what I mean?
I think you want to try to balance around the average case. And that way, if you can differentiate them, think of it kind of like the distribution, a normal distribution. You can balance the mean, but you can also balance the standard deviation. You have 2 variables at play with a normal distribution. So start with the average case, but then you can start manipulating how extreme the different values are. And that can create very different kinds of cards. We want to eliminate any extremes for which there is no counterplay.
This is so fun. This is nice. That's fine. You can't, yeah. You have to move that. Because otherwise, I mean, this is really the True. We have to do that. So, I said that literally changed that. Cause it still be like meetings, it still is. Yeah. Yeah. Wait, pause. Okay. So wait, basically this is. I can see you there. What the, yeah, but it's like. You get that. There's high level. These are basically. You can do 6. Yeah.
Yeah,
We do 6 damage, you have to remain within.
let's stay within 1 to 5 for now.
Problem. You want to do. Are we with it? Yeah. Yeah. You drop the stream. Just play that. I know. The even this way is so weird. The reason is you could Jenny's button mashing. Here. Coffees. I got it. Even people never know. Okay, you're really just completely see. Let's just think about like he's really weak. This guy is boom. But these are all recording basically. That means it's like a bank. You get like you're like what? Let's add one more formula.
How are we doing? Anyone have a full set of cards they feel confident in? Yeah,
Not exactly at 0, but it's between 0 and 0.4.
yeah, that's good. I actually don't think it's possible to hit absolutely everything right on 0.
Yeah, it's like, I think anything that costs 1 seems to be like, the lowest you could probably get is like a 0.2.
And it's like, I think you mentioned I think it was yesterday, that even if it is mathematically correct, that doesn't necessarily mean it feels good to play.
Right.
It could just be.
Yeah, that's a good place to start, but certainly these can be mathematically balanced in a way where you can imagine that Hero has the highest strength of every other card, and every other card just deals drastically more damage than the hero. It's still right to choose the hero every time, even if mathematically they look balanced, because damage is worth something. We're making an assumption that we have equal distribution across these cards between 1 and 5, and if that's not the case, then the strength 5 card is going to be the right pick every time, as long as the damage is higher than the cost. All right, so I'm actually curious to hear what this draft is. So let's see what one example is, and then with the last few minutes of class, my challenge to the rest of the class will be come up with another equilibrium, or to poke holes in this equilibrium. But let's hear one. What do we have? What do we have for costs first and foremost?
2, 1, 2, 4.
2, 1, 2, and 4. For strength.
4, 4, 5, 5.
And damage.
4, 3, 3, 5.
Interesting. What do we get for totals for value?
0, 0.2, 0.4, 0.4. That's it.
Okay. So we've reached a much better mathematical balance. In this meta, which cards are you putting in your deck?
And there's still 10 max health, right?
Yep.
If you went all hero, then and the other person went all fighter, then you would die first, right?
You would die at the same time.
On the same, on the same turn. You would die bigger.
But you would always,
I mean, it's
you
like,
would always win against any other card.
What would
Just heroes.
hero would stick around against fighter, but the cost minus damage, or sorry, damage minus cost is 1 in the same way that this damage minus cost is 1. So a deck playing hero versus a deck playing fighter, one person takes 4 plus 3, and another person takes 5 plus 2.
But what about like the other ones?
I guess the hero would lose then, because the hero is going to take that cost on play. So the fighter is a better choice than the hero. At least in the all hero versus all fighter deck. The fighter deck wins every time.
you know what happens if you get sent to 1 HP? Like, who dies in that case, or like, you just like.
It's about when it happens.
Okay.
So if you had a whole deck of fighter, whole deck of hero, the first round goes through, we each start with 10 life. One person plays a fighter, one person plays a hero. They take immediately 2 and 4 damage. And then when damage resolves, the player who picked the fighter takes an additional 5 for a total of 7. The player who picked the hero takes an additional 3 for a total of 7. So each person is at 3 health, start of the second turn. You put your cards face down, you turn them up and take their cost and damage. The fighter takes 2, going down to 1. The hero takes 4, going down to -1 and loses instantly. So the fighter player wins in that case.
But against cleric and thief, but hero.
Oh yeah, there's no reason to pick thieves and cleric. We could look at the thief versus cleric metagame,
Yeah,
but it's dominated by either a choice of fighter or a choice of hero. Yeah, that's interesting. It's interesting in that it is mathematically balanced, but I think that this is such a equilibrium that is not necessarily one that creates an interesting metagame. There's a solution to this. If I'm looking at this, I make a deck of all fighters. Are there other solutions? With the last couple minutes of class, here is an idea. Can we come up with an idea that is at least as mathematically balanced or close to as mathematically balanced that might create cards that seem more interesting to choose comparatively? Yeah,
Is it okay to have decimal values for like cost and damage?
let's keep them at full values for now.
Never mind. Cause I got one where it's like all the total is clear.
Oh yeah, I think if you do partial, then it is absolutely possible to get to perfect mathematical balance. But then partial points of damage feels a little bit weird. Partial points of cost.
Yeah, 4.48 strength.
I will say that it's very hard for me to like try to think of a metagames. Try to think like, well, how would I make this balance? Because I run into the issue of like what's stopping you like loading up on one thing and what's encouraging you to try something else.
Yeah,
You know?
yeah. So that comes from wherever you can create a weakness. So each card should have a strength and a weakness. If a card has strengths with proportion to everything and their weaknesses are nullified, then that's what creates the need or the desire to pick all of one card. So I'm not going to reveal the book's answer to this quite yet. But I'd like you to think over the weekend about what you would do here and see if you can come up with an interesting balance for this. And this is exactly what we're going to be doing to Harmony as well. So we have draw and discard and heal and damage. And those 4 values, depending on the cards that play, there's going to be a resource cost. But when you do, you're going to get the benefit of those 4 values. So the question is, relatively, how valuable are they comparatively to each other? And how should cost play a factor? Yeah.
So when we're doing that, are we just assuming for that game that you will have 10 of each like resource? Or can we play with that number as well?
You're definitely playing with that number. Okay. Yeah, the resource cost, there's going to be a benefit to playing a low value card because you can play it early. There's going to be a cost to playing a high value card because you can't play it until late.
No, I mean like the actual number of resources you have in your deck. Is that fixed at 10 per, or is it, can we play with that number?
You can play with them. So look, for the moment, the actual the paper that you will be writing that is required is based on the decks that exist. Balance the existing decks without changing them. And an extra credit opportunity for undergraduates and requirement for graduates will be to introduce new concepts and or mess with the existing cards to, you can change distributions, you can change mechanics, you can add new mechanics, but whatever you do is going to have to be shown to be mathematically balanced. You're going to start with a basic balance that is mathematically valid, and then from there you're going to do analysis on how does the gameplay play out from this? What are the balance issues? Even though mathematically it looks balanced, what should you do to change that without drastically changing the mathematical balance? To make it interesting and engaging to play. So the end goal of the Harmony card game is to create something that is fun to play.
Will the change that we'll be making include changing what a card does, like instead of doing more or less damage, doing more or less, replacing do damage with heal?
Potentially. The issue that I have with that is that they're supposed to be thematic decks that do different. The reason we have those different draw, damage, discard is that each of those decks have an identity. There's a way that they're trying to win the game, and there is a way that they are trying to protect themselves to be able to recur that. So make sure that if you're doing those kinds of changes, what you do is you give decks an identity. Kind of a path to victory, a path to play. It should feel thematic.
Yeah, because there were some decks playing where it was obvious, the theme was obvious, but it was that path wasn't very good one. For example, C versus almost all the others.
Yeah, but if we change the associated costs of cards, if we change the value of draw and discard so that maybe it costs more to do a point of 1 than the base balance, it costs a lot less of another. Based on that base balance, you can drastically change the balance of each of those decks just by saying, you can say that for cost 1, you can do damage 50. Now, whatever deck has that card is the best deck. So you have full power over all of those variables, and the goal is not to create something that's overpowered, but to create 4 different decks that play differently, but have an equal chance to win.
Or at least run.
Yeah. So I'll see you next week for that.
Yeah.